Okay, I want to go over the examples we talked about in class on how to factor by grouping. So we're going to do 3 that are already somewhat done for you, but have key things to watch out for. So directions are just going to say factor. So first we have a times the quantity n minus 1 plus 3 times the quantity n minus 1. So again, what we were talking about in our notes is that when we're factoring by grouping, we have 4 terms in our polynomial. We group them 2 by 2, look for a GCMF for each pairing, and then look to see if there's a binomial they share in common. And if you notice in this one, they both have an n minus 1. So what we're going to do is we're going to factor out that n minus 1. So I'm going to divide both of these by the quantity n minus 1. I'm going to put that binomial in the front, because that's what you do with a GCMF, pull it out. And then to figure out what gets left behind, look what ends up happening. On the first one, when we divide a times the quantity n minus 1 by the quantity n minus 1, all that's left is a. And then what do I get when I divide positive 3 times the quantity n minus 1 times n minus 1? We get positive 3. Or, if you notice, it's just the coefficients that are in front of those two binomials, including the sign in front of the second one. And that's what we do. Okay, so let's try another one. And each one of these has something unique to it. So in this one, we have 2x times the quantity x plus 2, and then minus the quantity 2 plus x. So what we're looking for is an absolute match of what's inside the parentheses, that those two binomials match exactly. So on the left binomial, we've got x plus 2, but in the right one, we have 2 plus x. So that's not exactly the same. So then I think about things that we've learned in the past, and one we've learned is a property called the commutative property of addition, which says the order that we add does not change the result of the addition. In other words, x plus 2 will give me the same exact answer as 2 plus x. So I can actually look at this problem as being the same quantity inside the parentheses, and that's only because of the commutative property of addition. So let me go ahead and rewrite this problem with that change in it. So we have 2x times the quantity x plus 2 minus the quantity x plus 2. So at this point we do have a match of my binomials. So we're going to go ahead and divide both of these quantities, these terms, by the x plus 2, the binomial GCMF, so to speak. So out he comes in the front. I factor out the x plus 2, and then I look to see what's left behind. So I've got 2x from the front, and then it says when I divide negative x plus 2 by x plus 2, I get negative. But what am I really getting? I'm getting a negative 1. So you can always remember, if you don't see a coefficient, it's 1, and that's going to match there. So that's going to be my answer. Go back. Always forget to box these. All right, let's try another one. Now the next one is something to really watch out for, because it is going to be a helpful tool. We have 4x times the quantity x minus y plus 3 times the quantity y minus x. Now, in these two parentheses, while they have the same terms x and y, they have opposite signs from each other. So my job is to try to figure out a way to get the y minus x to turn around and look like x minus y. And if you think about it, if I factor out a negative, that makes the y negative, and it makes the x positive. And then when you look, we do have a match. Okay? So the question is, what on earth do I do with that negative? Well, what I do is I bring it up. So here's what the problem looks like now. We have 4x times the quantity x minus y minus 3 times the quantity x minus y. So yes, we do have a match. We will factor out. Let's see. Divide both by x minus y. So when you factor out the x minus y, what gets left behind is going to be 4x divided times x minus y divided by x minus y is 4x. Negative 3 times the quantity x minus y divided by the quantity x minus y is going to be negative 3. So again, they form what's in your second binomial, and I forgot to circle that up over here. Actually, let's not circle, do it from there. Let me see, I want to, there. We're going to circle it from here. Okay? And then that's your final answer. Alright, let's try another one. So now the next grouping I'm going to give you, no longer are you going to be seeing things already pre-factored for you. So we have 5a minus 5an minus nx plus x. So job number one is to check to make sure you don't have an overall GCMF of all four terms. And in this one I do not have it. Next you want to check out if you can pull out a GCMF of the pairs as they are written. And this guy has a 5a in common. And the next grouping has, and here's where it gets to be a little tricky. If that third term is negative, I will have to pull out a negative x from both of those. Okay? So we're going to have 5a, and then we'll figure out what we get left behind. So 5a divided by 5a is 1, and then it says minus 5an divided by 5a is n. Now we're going to pull out a negative x, and negative nx divided by negative x is positive n, and x divided by negative x is negative 1. So we have the situation that happened in number 3 in this problem, which means in order to get the n's and 1's to be in the same orientation, I'd have to factor out a negative 1. Oops, sorry. And a positive n becomes a negative n, and a negative 1 becomes a positive 1. So the thing we have to remember is to bring that negative up to the middle term. So your problem at this juncture looks like 5a times the quantity 1 minus n plus x times the quantity 1 minus n. So you should notice we do have the common factor of 1 minus n. So I'm not going to show the division anymore, but I'm going to pull him out, 1 minus n, and then remember to get the second binomial, I'm just going to pull out the coefficients. So that would be 5a plus x, and I'm not really pulling them out, they're the result of dividing each of those terms by the 1 minus n. Okay? Alright, we've got a couple more. So we've got the next one, ax plus by plus ay plus bx. So in our notes we talked about we need to group them so that we can pull out something, and the way that our terms are listed, we don't have anything in common in the first two. Ax, by, no overlapping. So what we talked about was combining up like terms, and we have two options for how to combine them. We could combine a's with a's, b's with b's, or we can combine x's with x's and y's with y's. Okay, so I think what I'm going to do is to rewrite this problem so that the a's are next to each other. The other thing I notice is that my x comes in front of the y, so when I am rearranging my b terms, I'm going to put the bx in front of the by, so that when it comes to the b's, the x is the first one in its group. Okay, and then we're going to pair them up. So these two have an a in common. These two have a b in common. So this gives me a times, oops, I wanted to change that. A, and then ax divided by a is x, plus ay divided by a is y. And then we have pulling out a positive b. And bx divided by b is x, plus by divided by b is y. We do have a common binomial. That's our miracle that we hope to happen. So we're going to pull that, divide that out in front. And what's going to remain behind would be a times the quantity x plus y divided by the quantity x plus y gives me an a. And then it says plus, and b times the quantity x plus y divided by the x plus y gives me a b. And there's my answer. All right, let's try another one. Got two more. 10a squared plus 20ac minus 6a minus 12c. So again, we're looking for GCMF to begin with, and I'm seeing even, 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 even. So for sure, I know what I can pull out of each of them is a 2. And then I'm going to look at variables to see if there's a variable they all have. We have a, and then we have an AC. No. So already from the first one, it doesn't have a C, so I needed to have both in order to be able to pull it out. So that's what I'm going to pull out is just a GCMF of all of the terms. So there's a possibility of having 3 GCMFs in these. The first one would be the GCMF of all 4 terms. Then you would pair them up and look for a GCMF of each pair. And then once you do that, there should be a binomial GCMF, so to speak. So when I divide by 2, I get 5a squared plus divide by 2, 10ac, divide by 2 minus 3a, divide by 2 minus 6c. Okay, now we're going to pair them up, making sure, yep, I definitely see something they have in common, 5 and a. And in the second group, I'm going to have to pull out a negative 3. So I still have the 2, but now when I pull out the 5a, that leaves behind 5a squared divided by 5a is a, and then plus 10ac divided by 5a is 2c, and then I'm going to pull out a negative 3. Negative 3a divided by 3 is a positive a, and negative 6c divided by a negative 3 is a positive 2c. And if you notice, we did end up with like terms that are binomials. So for my final answer, I get 2 times the common binomial, a plus 2c, plus the coefficients that I had pulled out. So those the second set of GCMFs. So I have 5a minus 3. And there you go. All right, and we got one more. And this last one, we've got 9x squared minus 3xy. Ooh, might we have a GCMF of all of them? Minus 2, nope, ay plus 6ac. All right, so no GCMF here. So I'm going to pair them up 2 by 2. And these two have a 3x in common. These two, because of him, a negative 2a in common. So when I pull out the 3x, what's left behind? 9x squared divided by 3x is 3x. And negative 3xy divided by 3x is negative y. And then when I pull out the negative 2a, negative 2ay divided by negative 2a is positive y. and then 6ax divided by a negative 2a is a negative 3x. Now we ran across the problem that we did in the beginning where my terms are the same but they're in the wrong order, so I can combat that by pulling out a negative, which makes the y negative and the negative 3x positive. And then the other thing is to take that negative and combine it with the negative there. So my problem now looks like this. 3x times the quantity 3x minus y plus 2a times the quantity 3x minus y. So we do have the common binomial, 3x minus y, 3x minus y. And when I factor, that binomial gets factored out, and forming my second binomial would be those two. So my answer is going to be 3x minus y times the quantity 3x plus 2a. Okay. Now, I want to address the situation that we just had in this problem and offer you a suggestion. Probably one of the biggest places we make mistakes is by factoring out when we're dealing with negatives, and we factored out of some but not others. So what I'm going to suggest to you on this problem is, what if I decided I don't like having that negative in the middle? Why don't I just go ahead and rearrange terms so that the negative is not in the third position? So if I change those guys up, I get 9x squared minus 3xy plus 6ax minus 2ay. Now, I'm not going to go through step by step as I did before. I'm just going to kind of quickly factor through. So in the first two, so if I group them up, I'm going to pull out the 3x, which gives me the 3x minus y. And in the second group, I'm going to factor out the positive 2a, and that gives me my 3x minus y. So this is a little bit nicer in that I don't have to contend with that negative. I don't have to do that extra step I did in red here, where I had to pull out the negative and then distribute that to the middle. So use this as a strategy if you are concerned about your negatives. See if you can rearrange your terms so that the term in the middle, which would be the third term, would be positive. Now, sometimes it's impossible to do that, but if you can, give it a shot. All right, good luck with this.